Hey there. I've decided to go ahead and wrap up this section on 2.6 on rational functions. When I say wrap up, I gave you the first part. I kind of did a whirlwind. I didn't do all the problems that I wanted to. So I'm going to go back to those pages. And I think there's like 3 more problems on this topic. And then I should, so this is part 2, I guess is what I'm doing. So then that should wrap up this concept on rational functions. So let's take a look and see what I got. You may remember from that other video that at least I got to talk about what happens with a rational function like this one, where the degree at the top, well, it could be at the bottom too, but the degree at the top and bottom, you consider if it can factor, because if it can factor, then what looked like a asymptote, right now it looks like x equals 1 is a, of course, it's undefined there, could be an asymptote, but if it could factor, which this did, and you make the denominator go away, which it does, there is no denominator, so there's no vertical asymptote, but that's called a hole. X equals 1 is a hole. So just keep that in mind, and then I can fill in the rest of the problems. Maybe I can even show you that what looked like at the end, y equals mx plus b, it's a line. This picture right here should be a line. Should be a line. So y equals, let's see, get rid of this piece right here. Get rid of that piece there. I'm going to go, that gives me my fraction. Okay, here we go. X squared plus x subtract 2. That's all over x subtract 1. So I claim that the picture of this is going to look like the equation of a line, which is y equals mx plus b. Y equals 1x plus 2. There's your m, there's your b. It'll look like a line. Zoom standard. Sure enough, looks like a line. The thing is, I can't use 1, so right here, there'd be like a circle right there. So if you're going to graph this, you'd have to go forever this way and that way. When you get up to 1, which looked like it'd be 1, 3, put a 1 there, it looks like 1. There would have to be an open circle right there. And to justify it, if I go second table, you'll see at 1, there's an error right there you can't have. So back to the graph. Is there an X-intercept right here? There was. There was. X-intercept, there is. So if I want to go second, do that again, second calc, that's the 0 is the X-intercepts. And then left bound, let's make it like right over here. That's the left bound, which looks like about -3. And right bound over here, maybe 5. It's going to look in between, and it should find that answer right there. It should find that. -2. So your X-intercept is -2, and as an ordered pair, it would be -2, 0. Is there a Y-intercept? Well, if X is 0, then it gets you the Y value, which is the Y-intercept. So it's a +2. So when X is 0, it's a +2. So since there's a hole, there is no vertical asymptote. So you might say none. Any horizontal asymptotes? Well, if the degree at the top is 1 more than the degree at the bottom, the degree in the numerator is bigger. Let's see. Back to your rules. At the top is bigger. Right here, the bottom. The degree at the top is bigger. There is no horizontal asymptote. So that would be none. Slant asymptote, well, it turns out to be that itself. So that would be y equals x plus 2. Jeff, I thought you had to do long division. Sure, go ahead and do long division on this, and you'll find out you'll get that. You will. Relative mins, none, because there's no turn. There's no turn. Likewise with relative max, none. And we've already identified the domain. You just can't use 1. And the range, you can't use 3. And the reason why you can't use 3 is because there was a hole right here. Remember that? There was a hole right here. And the picture looked like this. Went like this. And that's at 3 right there. This is at 3, and this is at 1. So you can't use 1, can't use 3 for the y. Okay, it looks like I've got this one. I'll go ahead and graph it and see what it looks like first. Y equals. I'll graph it, zoom in so you can see it. Okay, looks like a couple things are happening. It looks like you've got asymptotic behavior right here. There's a gap. And there's a relative minimum here, relative maximum. There's an X and Y intercept, it looks like it's right here. So a few things to consider. So if I go over here and say, okay, is there X-intercepts? It looked like it was 0, 0. You can confirm that yourself as well as here. Vertical asymptotes, yep. It looks like X equals. So if you factor this, or set it equal to 0, x squared minus 9 is equal to 0. You could go x squared equals 9. So x equals plus or minus the square root of 9, which is equal to the square root of 3. So those are your asymptotes, plus or minus square root of 3. Horizontal asymptote, none again, because the denominators, the numerator power is bigger than the denominator. Slant asymptote, yes, there is actually. So what you'll do is long division on the slant asymptote, and I'll do it up here. X squared minus 9, and that goes into x cubed, and no x squareds, and no x's, and no constant. So I need a, to do this, I need a x here, which gives me my x cubed. And x times negative 9 is negative 9x over here. Subtract. This is gone. Okay, so that's going to be a positive 9x. And you'll see bring down nothing and nothing. So right now I'm done. So the only answer that I've got left, because that's called the remainder, x squared doesn't go into x. So my slant asymptote is going to be y equals x, y equals x. And if you look at the calculator right here, it looks like it's going like this. Y equals x. Relative minimum maximum. Yeah, it looked like there was, so I'm going to have to find those things by using those key features in the calculator. Minimum, for instance. And it looks like here's a minimum value. So I have to pick something to the left of that. Don't go too far over here, the left of this. So let's see, that looks like, gosh, right here at 1, 2, 3, 4, 5, 5, maybe 4. I'll try 4. Yeah, I think that's okay. And then over here would be maybe 7 or 8. Sure. Okay, so it looks like I've got it. There's a cursor right there. 7, okay, I'll do 2 decimal places. So 7.79, 7.79. So you go y is squiggle, squiggle, 7.79. And then relative maximum is down below here. So let's see, do it again. Okay, so the problem is I can't see anything down here. So I think what I'll do is I'm going to change my window screen so I go down farther, which takes the curve and brings it up higher. If I go down farther here, maybe to -20, my curvy thing should be, there it is, should be a little higher. So I'm looking for that one. Maximum. Okay, so left bound, let's pick over here like -8. Right bound is maybe right about here, maybe 4, maybe 4. Might be okay. Oh, yeah, well, the problem is I went way too far over here. Let's try that again. -8 was a good choice. -8. And -4 is what I meant to say. -4 over here. And meant to type in as well. Okay, let's see. Yeah, it's giving me a cursor. So negative, very symmetric, -7.78, -7.79. Okay, now the domain, I have to exclude these guys. So the domain would be squiggle x such that real numbers, x just can't be plus or minus square root of 3. And the range is a little more challenging. Now the range, I can go low to high. Is there any y values as I move up? Like you say, what about in here? That's missing, but it's found over here. So any of the y values that are missing here are actually found over here. And likewise here, there's missing here, but it's found over here. It looks like there's no y values whatsoever that I'm missing. So all real numbers. Like that. Okay, next one here. Okay, I'm going to graph this. Get rid of that. X in the numerator, and again that x squared. Subtract 9 from like the last problem. Oops, that was weird. There it is, x squared, subtract 9. Just like the last problem. You know what? I'm thinking I made a mistake in the last problem. I went square root of 9 is square root of 3. I need to go back and change that. You wondered about that, I'm sure you did. Yeah, square root of 9 is plain old 3. So I made a mistake there. Happens to all of us. Change this. This would be equal to plus or minus 3. Plus or minus 3. There you go. And down here, the domain, plus or minus 3. I got that. Back over here, same thing. The vertical asymptotes are going to be x equals plus or minus 3. Now the x-intercept, I'm going to take a look and see what the graphing calculator might indicate. Maybe the origin again. I'm going to go back and do zoom standard this time. It looks like that's going to be the x-intercept, which you can verify yourself. So again, 0, 0, and 0, 0 for the y-intercept. Horizontal asymptote. Now, when the numerator is smaller than the denominator, that's when you get the y equals 0 as a horizontal asymptote, and you can check that out in your rules. Therefore, there's no slant asymptote. And relative mins and maxes, I'd have to make sure that there's a turn, like right here. Is there a turn that goes back up? Not at all. This continues to get closer and closer to the horizontal asymptote, continues to get closer to the x-axis. So no and no, no, no. And back to the domain, just like the previous problem, you can go, well, let's do interval notation for this instead. So let's see, domain would be from -infinity to -3, union, and you pick it back up again at -3, and you go to 3 in union, and then you go from 3 to infinity. That would be the domain. And then the range, it looks like it covers everything. I mean, particularly this one. See, it covers everything. That supersedes these two right here. So double-legged R. All right, and then the last problem here, and these guys, I need to find all these things. So I might as well go ahead and graph it again. Oh, that again gives me my, unless this factors, which it doesn't look like it does. Okay, let's take a look here. No, that won't factor. No, it won't factor. So this right here is indicating your vertical asymptotes, which is x is equal to plus or minus 3 again, which back down here at the domain would be all real numbers except those. And the rest of it, I'm going to look at my picture. Okay, zoom standard again. Okay, I know that there are asymptotes that are right here, right? Okay, the question is, it looks like there's some gap where all the other ones had something going on here. It might be outside the screen viewing screen. That's weird. It might be outside the viewing screen. So I'm going to go window, and I'm going to make these like -20 to 20 and see what happens. So -20 to 20, -20 to 20, and see what happens. Okay, you might think that's it. I'm going to do it one more time and even go out further. I'm just not quite sure I'm convinced yet. So you could do a zoom fit. You could do a zoom out. I'm just going to make this negative. Let's go -50 to 50. I'm just wondering if there's something over here. Look at that. There's something right there. Of course, these are not the right asymptotes. There's something right there. So I'm going to keep my -50 to 50 and bring in my x values in this way. I'm going to keep my -50, 50 for the y. I'm going to go back over here and go -10 to 10. Aha. See, there you go. So it looks like there's relative mins and maxes as well. And x and y intercept looks like it's the origin again. How do I know? Well, y-intercept, look at this. I made a mistake. It looked like it, but if I let the x be 0, I'm left with 2/9. So I made a mistake. When x is 0, I'm left with 2/9. I'd better find out about the x-intercepts if in fact there are any. I'm curious right now. So I'm going to zoom in right here. Or how about if I do and just see if the calculator gives me any zeros. I'll just go ahead and go maybe from -2 to 2, -2 to 2. I'm just curious to see if it's going to give me anything. There are some. There are some. And so there's one, there's another one sitting over here. And I bet you because it's symmetric, it's going to be the negative. So I think X-intercepts equals plus or minus decimal 1.495, maybe 3 decimal places. Horizontal asymptote, there are none. You know why? Well, because the denominator is bigger than the numerator, power. Slant asymptote, there isn't one. It's because to be a slant asymptote or have one, you have to have the degree exactly one more in the numerator than the denominator. And you have 2. The degree is 2 more. So there's no slant asymptote. And relative mins and maxes are going to be found likely right here, which you guys know how to do, and I'm not going to attempt to do that. You know how to do those. Oh, and the range. Gosh, it looks like the range is going to end up being as low as whatever here is to as high. See how the gap is? So it's not all real numbers. I'll just say it's not all real numbers. It's a little more challenging for the range because you'd have to have a decimal approximation, and then I'd have to zoom in to see if there's any bumps or turns right here, which is not a difficult thing to do. If I went zoom in right there at the origin, let's hit enter. See, there's some turns up here. So I'm going to go back to zoom 6 and then do zoom in. You see, it looks like there's going to be another X-intercept over here. There's another relative, let's say, maximum there. The ones you're going to get on your exam or anything else, it's not going to be as complicated as this particular problem. Not at all. So I'm just going to let this one go because of the approximation factor is going to be off. I won't be able to get it too precise. The other 4 or more problems that I've done are better problems and are very similar to your homework that you would have been working on. And that leads me to having finished. So with that said, I am now done with 2.6 or rational functions. Until the next section, take care.